Hello, grade 7s. In today's lesson, we are going to begin our second last unit of study in Math 7, that dealing with patterns and expressions. Learning outcome for today is to use patterns to describe the world and to solve problems. What do we know about patterns? Patterns can come in many forms, they can come in many shapes, they can come in many numbers. The important thing that we're mainly interested in a pattern, whether it's like a pattern between shapes and numbers, is once we can identify the pattern, we can then use the pattern to make predictions about what's going to come in the future. To describe a pattern, what we generally do is we identify what the first number or shape we start a pattern with is, and then describe how we get to the next shape or number in that pattern. Okay, so let me give an example here of how we would do this. I'm just going to call this example 0. Okay, so example 0, I'm going to say, describe the following patterns. Describe the following patterns and predict the next term in the pattern. Okay, so let's do A. Let's say I have 20, 40, 60, 80, and we'll say ... to indicate the pattern keeps going on, but we're not sure what the next term actually is. Okay, so the way we want to describe the pattern is we want to, first of all, identify what is the starting number in the pattern. So what I would do here is I would say starting with 20. What do you need to do to get to the next number in the pattern? Well, if you look at that, if you start with 20, what we're clearly doing to get to the next number in the pattern is we're adding 20. So I'd say starting with 20, I'm going to add 20 to get to the next term. How about this? Let's do B. And we'll say we've got, I'm going to do 4, 12. Let's do 36. Okay, I'll do ... Okay, so once again, to describe the pattern, what you want to do is identify, first of all, what are you starting with? So I would say starting with 4. Okay, what are we doing here? So we're starting with 4. So how do you go from 4 to 12 using some kind of mathematical operation? Well, you could add 8 to go from 4 to 12, because 4 plus 8 would be 12. But then that needs to be consistent. Then to go from 12 to 36, I would need to add 8. Is 12 plus 8 36? Nope. 12 plus 8 is 20. So what else could you possibly do here? Well, how else can you go from 4 to 12? How about multiplication? 4 times 3 would be equal to 12. And then let's check to see if we can do it for the next term. And then 12 times 3 would be 36. Okay, so that's correct. So what I would say is, starting with 4, I would multiply by 3 to get to the next term. Now, we also needed to identify what the next term is. So let's go back to example A. Starting at 20, add 20 to the next term. So 20 plus 20 is 40, plus 20 is 60, plus 20 is 80, plus another 20 would be 80 plus 20 is 100. So that'd be the next number in that one. How about this one? 4 times 3 is 12. 12 times 3 is 36. What about 36 times 3? Well, we can do the long multiplication for this. So 36 times 3. I mean, I know what it is in my head. I'm just going to show the work anyway. 6 times 3 is 18. Carry that 1. 9 times 9. 3 times 3 is 9, plus 1 would be 10. So that's going to be 108. 108 would be the next term here. All right, how about this? Let's do a shape. Although we'll get into shape in the next problem as well. I just want to start off easier. Okay, let's say we have triangle, square, pentagon, dot, 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 dot. Okay, so what are we doing here? Well, we're starting with a triangle. So I could say starting with a triangle. Okay, and what am I doing? Starting with a triangle. How am I getting to the next shape? Well, what's going on with the shapes here? So triangle is a 3-sided shape. Square is a 4-sided shape. A pentagon is a 5-sided shape. So really what I'm doing is I'm just adding another side. So I'd say starting with a triangle, add one side to get to the next shape. So what would my next shape then be? 6-sided shape. What's a 6-sided shape? It's a hexagon. So you'd have 1, 2, 3, 4, 5, 6. Okay, so those are some basic patterns. A and B dealt with patterns that involve numbers, and then C involved patterns that involve shapes. And again, the way we want to describe a pattern is we identify what are we starting with and what do you need to do to get to the next term in the pattern. When I say term, it could be like a number or the next shape in the pattern. Now, let's look at something a bit more complicated. So it says, given the following pattern of squares, describe the pattern of squares and then predict how many squares are in the next item. Okay. Well, easy enough to identify what we're starting with. So I would say starting with 1 square. Okay, what are we doing to go from this shape here to this one? Well, maybe we should describe it in 2 ways. Let's look at the bottom of the shapes. Let's call this the base. And let's look at the side of the shape, which we'll call the height. So what am I doing every time to the base? I'm adding 1 square to the base. So I could say starting with 1 square, add 1 square to the base. And I'm also adding 1 square to the height. Now, it's not quite good enough to describe it like that, because if you did this, so if I said starting with 1 square, add 1 square to the base, and 1 square to the height, you would have a shape like this. Okay, so you'd be missing this 1 square here. So it's a bit just difficult to describe like what to do. So I'd say starting with 1 square, add 1 square to the base and 1 square to the height. And maybe I'll do this. I'll say, and fill in any remaining space to form a perfect square. Form a larger square. A little bit wordy. Perhaps you could have come up with something that's a little bit better in terms of how to describe that, but that's good enough. Okay, now B says, now we've described the pattern, it says predict how many squares would be in the next item. Well, we should be able to identify how many squares are in this one. So the last shape we see is one where you have 1, 2, 3, 4. 1, 2, 3, 4. Okay, just fill this guy in. Okay, so to get to the next shape, we need to add 1 square to the base. Okay, so I'll do it over here. And then 1 square to the height. And then we need to fill in any remaining space to form a larger square. Okay, so we can do that. Fill in the remaining space. And how many squares we have? We can multiply. So I have a base of 5 and I have a height of 5. Therefore, 5 times 5 would give me 25 squares. Okay, so a little bit tougher compared to example 0, as I called it. Okay, example 2, student observes the following pattern dividing several numbers by 9. So we have 1 over 99 is 0.010101 dot dot dot. It's a repeating decimal number. 2 over 99 is 0.020202 dot dot dot. 3 over 99 is 0.030303 dot dot dot. Okay, so first things first, describe the pattern. So let's do this. Again, the way to describe a pattern is you say starting with the first term. So what's the first term? It's 1 over 99. In fact, the easiest way to describe this one would be to do it in terms of the fraction. So I'll say starting with 1 over 99. What are we doing to get to the next term? Well, we're not doing anything to the denominator. All we're doing is we're adding a value of 1 to the numerator. So I could say starting with 1 over 99, add 1 to the numerator. To get to the next term. Okay, and this is predict the next three patterns, terms in the pattern in terms of fraction form and also in bar notation. Okay, maybe we should start off just by going up here and putting these guys into bar notation. Okay, so the way bar notation works is you identify which group of numbers are repeating. So the group of number that's repeating after the decimal is the 0, 1. Okay, that keeps repeating. Identify that group and put a bar on top. Same with this one. This one would be 0.02, put a bar on top. And then this one, what group of digits is repeating after the decimal? It's 0.03, and then put the bar on top. Okay, so it shouldn't be too bad to identify the next three terms in the pattern. Okay, so the last one we're at is 3/99, and to get to the next term, we need to add 1 to the numerator. So the next one is then going to be 4/99. And 4/99, look at the pattern with the repeating decimal. All that's happening is we're adding the hundreds position by a 1. So 4/99 should then be 0.04 with the bar on top. Then the next term, we add 1 to the numerator, 5/99, which is 0.05 with the bar on top. And then the final one, 6/99, would be 0.06 with the bar on top. Okay, so that one's a bit easier than the previous one where we had to deal with the squares. Now, I'm not going to solve this one. This one is completely brutal. This was actually a problem that was like presented to me when I was in university just by one of my friends. And at the time when I saw this pattern here, I was like trying to like apply like some of the most complicated math I'd learned in engineering to like figure out like what the pattern is. And it turns out the hint he gave is that there really is no mathematical pattern here. There's some kind of trick that's occurring with the numbers. And in fact, he said it's more likely that a kindergarten student would be able to identify the next number in the pattern here than like someone in university. So there is no math pattern. So there's nothing like adding 10, multiplying by 3, whatever. There's just something a bit weird about how the numbers are written. The only hint I would give you for this one right here is to try to talk it out, talk each line out in terms of try to identify how many numbers or how many numbers you have in each line, and then see if you can go from there. If this is totally optional, if you want to give it a shot and you think you can get it to me, you can go ahead and email me. Otherwise, you can just ignore this one because it is very challenging. All right, so in the MathLink 7 textbook, page 354, 355, you can do numbers 5 through 10. Again, if it does specify, describe the pattern, we want to do it by saying, starting with this, do this to get to the next term. And I will talk to you in the next lesson.